What's up, interweb? I'm going to do okay, everything's good here, I think. We're going to review for test number 3. Are these functions? The only thing you have to do here is look at the x's and do they repeat? 1, 3, 5, 3. The 3's repeat. So, and if they do repeat, the y has to be the same value, and it is not. So this one is not a function. But if the x's don't repeat, then it is a function. Number 3, evaluating the lowest terms. Square root of negative 100. Remember, the square root of negative 1 is I. So really, if you have negative under the radical here, just bring out the I. Square root of 100, that means that the negative on the inside of the radical goes away. Now the square root of 100 is 10 plus or minus 10 I. Well, that's it. Number 4, basically the same problem except it needs to be factored. Is there a factor of 32 where one of the factors is a perfect square? Yes. This is I, and the negative goes away. Square root of 16 times 2. 16 times 2 is 32. And the square root of 16 is plus or minus 4i square root 2. Once you take the square root of it, it comes out of the radical. Number 5. 5 plus 3i times 5 minus 3i. This is a conjugate. Same numbers, except one's a positive and the other one's a negative. But when you have a conjugate, all you have to do here is multiply the first number and times the first number and the second number times the second number. Because remember, when you have a conjugate, the middle term, the linear term, gets eliminated. So what we have here is 25 minus 3i times a negative 3i is negative 9i squared, because I times I is I squared. Now remember, I squared is negative 1. So we have 25 minus 9 times negative 1. It's 25 plus 9 is 34. Okay. Write the rational expression in lowest terms. Well, write the rational expressions in lowest terms. X squared. Now this is number 6, by the way. X squared plus x plus 20 over x squared plus 3x minus 28. Now we need to factor these two. Let's see if this is any better. Yeah, maybe. Okay, what are the factors of 20? that add up to 1. 4 and 5, right? So this is all, oh, wait a minute. This was supposed to be a negative 20. I'm sorry. Negative 28. Sorry. Okay. But when the constant is a negative, we're going to have x plus something and x minus something. Because remember, the last thing you do in distributive property is this times this. Positive times a negative is a negative. Now the factors of 20 are going to be 4 and 5. 5 times negative 4 is negative 20. 5 minus 4 is a positive 1. Same thing here. We have, this is going to be x plus something and x minus something. Now the factors of 28 that add up to 3 are 7 and 4. Positive 7, negative 4. 7 times negative 4, negative 28. 7 minus 4 is 3. So we're correct. These two are the same, so they can be eliminated. And we end up with x plus 5 over x plus 7. Combining lowest terms. This is number 7. 3 square root 17 minus 2 square root 13 plus 5 square root 17. Okay, these two are like terms. The square root, 17, 17. So we can do, what is that, 5? 3 and 5 is 8. Square root 17 minus 2 square root of 13. This cannot be combined with anything else. This is what we have. Number 8. Basically the same thing. Excuse me. 5 square root 18 plus 4 square root 29. 4 square root, what did I say, 29, 72. Okay, what are the factors of 18 where one of them is a perfect square? Okay, square root of 9 is 3. 3 times 5 is 15. Square root 2 plus square root of 36 is 6 times 4. Because remember, this is multiplication here. Was it 24? Square root 2. Now these are like terms. So this is 39 square root 2. Okay? Okay. That was number 8. Number 9. Five minus square root 7 times 5 plus square root 7 is a conjugate. So again, all we have to do is multiply the first numbers and multiply the second numbers. 5 times 5 is 25 minus. Now what happens here when you multiply square roots times themselves, the radical just goes away. Or you can think of it as the square root of 49, which is, we can do that, minus 49 So we have 25 minus the square root of 49 is 7. But see, the radical just goes away when you multiply them times themselves. So that's equal to 18. Number 10. Solve the quadratic. We have x minus 5 all squared equals 100. Okay, the thing to do here is you want to get rid of the square. Get rid of the exponent. So we take the square root. Now when you do that, the exponent just goes away, the squared. So we have x minus 5 equals plus or minus 10. Now you're going to have two answers here. You're going to have x minus 5 equals 10 and x minus 5 equals negative 10. So we'll add 5 to each side. So x is 15. Again, add 5 to each side. X is negative 5. Uh-oh. Oh, I threw away my graph. Give the domain and range. And I'm sorry, but I threw away the graph. Let's see if we can make something similar to it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If we have a hole in the graph, let's say right here. Okay. Now, domain goes from side to side of the x's. And range goes up and down. First, let's do the domain. Okay, where does it start? From left to right? Negative infinity. Up to, it goes up to, this is about to be 1. And, or the union of 1 to positive infinity, from here all the way. The range, okay, we have range again goes from the bottom to the top. The bottom is going to be negative infinity up to 1, 2, 3, up to 4, and with a union of 4 to positive infinity. Okay. That was number 12. Mm-hmm. Okay, 13 is find the horizontal asymptote and the vertical asymptote. And remember, to find the vertical asymptote, set the denominator equal to 0 and solve. Now the horizontal asymptote if the numerator is less than the denominator, or you can say the denominator is greater than the numerator, horizontal asymptote is 0. If the numerator is greater than the denominator, there's no horizontal asymptote. And if the numerator is equal to the denominator, it's the ratio of the coefficients. Okay, so number 13 is x cubed plus 10 plus 10 plus 8 over x squared. Okay, we have the numerator's exponent. These are the exponents. Okay, the numerator's exponent is greater than the denominators. So the horizontal asymptote is none. The vertical asymptote is x squared equals 0. Take the square root of it, so the vertical asymptote is 0. Mm-hmm. 14 x minus 4 over x squared. Okay, so again, our vertical asymptote is x squared equals 0, square root. So our vertical asymptote is 0. Horizontal asymptote, the denominator is greater than the numerator. The denominator is greater than the numerator, so our asymptote is 0. Okay. And 15 is 5x over x minus 2. Okay, so our vertical asymptote is x minus 2 equals 0. Add 2 to each side, so our vertical asymptote is 2. Horizontal asymptote is if the exponent of the numerator is equal to the exponent of the denominator, it's the ratio of the coefficients, the numbers in front of the letter. So the horizontal asymptote is 5 over 1, which is, of course, just 5. Okay. Well, I hope y'all appreciate me doing this. I'm missing my nap. It's nap time now. Okay, now I forgot where we were. 16. Mm-hmm. Okay. First of all, we have a conjugate here. This is 4 plus x times 4 minus x. And we want to set each one of these equal to 0. 4 plus x equals 0, and 4 minus x equals 0. Subtract 4 from, oh boy, subtract 4 from each side, and we get x equals negative 4. That is one of the vertical asymptotes. And the easiest thing to do here is just to add x to each side. That way we don't have to do any more steps than necessary. So x is 4. And the vertical asymptote is 4. And 17, find the inverse function of f of x equals 2x minus 4. First, we rewrite this as y equals. Now we exchange the x's and the y's. So instead of y, we put x equals 2 times y minus 4, right? Now we solve this equation for y. Add 4 to each side. X plus 4 equals 2y. Divide by 2. And we have x plus 4 over 2 equals y. Now we rewrite this as the inverse function, which is f minus 1 of x equals x plus 2 over 2. And that's all there is to that one. Now number 18 is a little bit more involved, but really not much. Just follow the rules for solving equations. And again, calculate the inverse function, INVER. This is number 18. This is the last one. So what if you have this? F of x equals 3x plus 4 over x minus 2. Okay, we rewrite this as y equals 3x plus 4 over x minus 2. Now we exchange the x's and the y's. So wherever we have a y, we're going to put x equals 3y plus 4. Okay, change the x's and the y's over y minus 2. Now we're going to solve this for y. Okay. So the first thing we do is we get rid of this, move this over here. And how do we do that? We multiply this side by y minus 2, and then we do this one, y minus 2. Okay, so we get, this is a y here. So we get xy minus 2 x to x here, I'm sorry, equals, okay, this is gone, 3y plus 4. Okay. So now we're going to move this 3y. I'm going to move the 3y over here. Because remember, we want to get all the y's on one side. So we have xy minus 3y minus 2x equals 4. Let me rewrite this because it's gonna kind of getting jumbled up here. Okay, so we have xy minus 3y minus 2x equals 4. Now we're going to move the x over here, and we're going to factor out a y. So we have y open, x minus 3, closed, add 2x to each side, equals 2x plus 4, right? Right. Now, again, we want to solve this for y, so we're going to get rid of the x minus, so we're going to divide by x minus 3. That cancels, so we get y equals 2x plus 4 over x minus 3. And we replace the y for the inverse notation. So we have f of negative 1 x equals 2x plus 4 over x minus 3. It's fun stuff, huh? Okay. That's it. Take care. Bye-bye. Bye, Bonds.